This is a simple HTTP client. It uses Python's request library to make a GET request on a given URL and then return the text of the HTML response. Here in the main, I am calling this function with example.com URL. Now let me save this file and run it. Then you will see the HTML of the example domain is returned. Before I create a synchronous HTTP client from scratch, let me show you the simplest way to convert any normal Python function into an asynchronous coroutine. So here I'm using asyncio library two-thread method to convert this fetch HTTP, which is a normal Python function, into an asynchronous function. What two-thread basically does, it calls this function with given arguments in a separate thread, and we can then await the execution of that thread. To run this function, I will comment out the previous one. Here first, I get an event loop using the asyncio library, and then use this loops run until complete method to run this coroutine. If I save this file and run it, then you will see it works as the previous one, but only this time we are calling a coroutine instead of a normal Python function. Even though this is simple and libraries like aiofiles use it, but it is not efficient because of the OS level context switching, which is heavyweight and is not scalable for highly concurrent applications. Now let's build a truly asynchronous HTTP client. For that to work, I need the host from the URL. I can get that using the URL parse method, which can be imported from URL library. And then getting the host and the path is as simple as accessing attributes of Python objects. So for this particular example, the host name will be www.example.com and the path will be /a/resource. The first step in making any network request is to open a connection to the host. For that, I am going to use asyncio open connection method. And here I need to pass the host and the port. So by default, the port for HTTP is 80. Now this open connection is of type coroutine, so I'm going to await it. And if you look, this returns me a tuple of stream reader and a stream writer object. I'm going to save them in two separate Python variables. Now it's time to send the request. If you know, HTTP is a plain text protocol, so we can construct the HTTP request using Python string. If you are wondering, I'm going to print it. So if I run this application, this is what the HTML request looks like. To send the request, I'm going to use write or write method. Now this method accepts data in bytes, but our request is in string. So we will use the request encode method to convert the string into bytes. Now this function writes data into buffer. It does not actually send the data. To send the data, we will drain the buffer using the writer drain method. Once the execution of this line is complete, the request is sent to the host and it is time to read the response. The HTML response will be a plain text, so we can store it in Python string. To read the response, we can use the reader read method, pass in a chunk size, and this read method is of type coroutine, so we have to await it, and I'm going to store the result of the read method into a variable data. Now this read method returns me bytes object, so before I append it to response, I have to decode this data into Python string. Now this is just one chunk. To read all the chunk, I am going to move this inside an infinite while true loop. And to break out of the loop, if I found that at any point I receive no data, I can just break out of the loop. Now before I return the response, I will first close the connection and then return the response. Now if I go ahead and run this, then you can see our function works. Now enabling HTTPS is simple. So if we find out that our scheme is HTTPS, then we can create an SSL context using SSL library and pass the SSL context here. And also the port for HTTPS is 443. So I will change the port to 443 and pass in port here so that we don't break for HTTP. Then I am going to set SSL context to none. and port to 80 for HTTP. If I save and run this file, okay, so this works for HTTP. Let me change it to HTTPS. If I save now and run the file, then you can see our HTTPS is also enabled. Now let me show you a very interesting Redis client. Here I'm opening a connection to my local host. The Redis is running on port 6379. And for Redis, we have RESP format just like HTTP. I have also printed it so you can see for yourself what that looks like. Now to run this, I will comment out my previous one. Use send Redis command, and I will send a ping command. So if I run this function again, so this is the RESP format. So the first line is the number of commands that I'm sending. The second is the length of the first command, and this is the actual first command. Here I am printing the response, which is this line. Quick shout out to this video's sponsors, zobdata.com. They build custom software, data pipelines, and LLM-based workflows. If you are working on something ambitious and want experienced devs in your corner, definitely check them out. All you have to do is fill this form and they will get back to you.